Chapter 10.6, Day 1, we're going to look at parametric equations. We're going to sketch a plane curve. One way to sketch a curve represented by a pair of parametric equations is to plot points in the xy plane. You determine each set of coordinates xy from a value chosen for the parameter t, so like it is chosen for us here. Plotting the resulting points in the order of increasing values of t traces the curve in a specific direction, and this is called the orientation of the curve. So again, just important to note, it's an order of increasing values of t. So as t increases, that's the way the curve goes, and so that's the orientation of the curve. And so we have to explain that. Sketch and describe the orientation of the curve given by the parametric equations. So in order to do this, we have a table here. And so what we're going to do is we know that t has to be between -2 and 3. So t will be -2, -1, 0, 1, 2, and 3. So what we do is we're going to plug in each of these values into each of these equations. So in order to get our x value, we're going to plug in t into this equation. And then to get the y value, we're going to be plugging into y equals t over 2. So let's plug in, for example, -2. And we're plugging it into here to get our x value. So you plug in -2 here, you're going to get 4 minus 4, so we will get 0. Then when you plug it into the y equation here, y equals, so -2 over 2, that will be a -1. So if we plot that point, 0, -1, then we know we're here, and that's when time equals -2. Then we continue to plot the rest of the points here. So if we plug in -1 into this equation, let me change this here. -1, we would get 1 minus 4, which is -3. Let me just do the x's first. At 0, we would get a -4. With 1, we would get a -3. 2, we would get 0. 3 squared, that's 9 minus 4, which is 5. Then if we plug it in to get our y values, then we would get -1 over 2 is -1/2. This would be 0. This would be +1/2. This would be +1 and 3/2. So let's finish plotting our points. We have t equals -2. So these are our ordered pairs. And then we have at x is -3, y is -1/2. So that is at time equals -1. And then at x is -4, y is 0. So that is when time equals 0. Then at -3, +1/2, that's time equals 1. And then at 0, +1, that's time equals 2. And then at time 3, we're at 5 3/2. So again, as time is increasing in this direction, it tells us what direction we are moving, right? We start here at -2, so curve starts at 0, -1, and so so we put the arrows to show the orientation of the curve, and then it ends at 5 3/2. We could also talk about it, because in the homework it's going to talk about, describe the orientation. We could say that it moves, well, I can't say from left to right. I mean, it kind of does. We can probably say it moves in a clockwise direction. And so that might kind of help you out with the homework. So try this example here. Sketch and describe the orientation of the curve given by the parametric equations. It gives us our parameters for t, and that should help you out. Try this out. So again, it gave us the parameters of -2 to 2, so you plug it in here. Now as t increases, that's how we know which direction our curve is moving. So you plug in -2 for x, then you get -4, and then you continue on, you get these x values. Then you plug in these values for the y, t's for the y, and you get the other values, the y values, and then you plot each point. So the first one would be -4, +18, then at -2, 6, 0, 2, and so forth, and so you know it moves in this direction. So the curve starts at -4, 18 and ends at 4, 18. We could even say that it moves, mostly from left to right. So now let's look at eliminating the parameter. So we're going to sketch the curve represented by the equations x equals 1 over square root of t plus 1 and y equals 1 over t plus 1. And we're going to eliminate the parameter and adjust the domain of the resulting rectangular equation. So we want to write a rectangular equation. And so what we're going to do is initially we're going to solve for t in one of the equations. Solve for t in one equation. Now it's up to you whichever you want to do, but sometimes one is more convenient than the other. So I'm going to take this x. So x equals 1 over square root of t plus 1. And so what we're going to do is we're going to go ahead and square both sides. So now we have x squared equals 1 over t plus 1. And we're trying to solve for t. So what I'm going to do is I'm going to switch these places here. Or, divide by x squared, multiply t plus 1. And so this is going to end up being t plus 1 equals 1 over x squared. Now we're almost isolated with our t, so let's subtract 1 from both sides. So we get t equals 1 over x squared minus 1. Let's get a common denominator, so let's multiply this 1 by x squared over x squared. And so we find that our equation here is going to be t equals 1 minus x squared over x squared. So now that we solved for t, what we're going to do is we're going to plug it into the other equation. So in this case, we're going to plug in t into, in this case, our y value, right? So we used x this time, so we'll plug it into the y. And so this is what this is going to look like. We have y equals t is this. So 1 minus x squared over x squared divided by 1 minus x squared over x squared, and then the plus 1. So notice I just plugged in the t here, wherever I saw t here. And then now we need to simplify. And so what we're going to do, just in order to make this complex fraction a little nicer, is let's multiply the top and the bottom by x squared. So essentially what that's doing is multiplying x squared to each term. So notice it'll cancel out the denominator here. It'll cancel out the denominator here. And then we're adding the plus x squared here. So this will be, these cancel. So 1 minus x squared over 1 minus x squared, so it takes care of that denominator, plus x squared. And then negative x squared plus x squared is 0. So we find that our equation is y equals 1 minus x squared. Now we need to adjust our domain. So looking at this equation here, we see that we have a restriction. So remember that under a square root, it must be positive greater than 0. So let's find out what it must be. And so you can probably see it right away, is t has to be greater than negative 1, right? Because it makes it undefined at that point. So really what we're looking at is that the values have to be positive. The domain has to be positive. Now, when we're looking at this equation here, we're looking at y equals 1 minus x squared. So think about what that looks like. So again, our domain, our x has to be positive. And so what that means is that we're going to be only on the right side here. And so how this is graphed is we're moved up 1, and then it opens up down. It's parabola that opens up down. And so I kind of get a little picture of what this looks like. Now I must do a table because I don't really know what direction this is moving. I don't know if it's going down or going up. And so how I figure that out is by plugging in t values. So it has to be 0, 1, 2, and 3. So again, what I'm going to do with these is this is the x here. So I'm going to plug in each of these t values for my x to find out what it is. And then I plug in that t value into my y's and find out what that point is. And so see what happens when I do that. So plugging in 0, I'm going to get 1 over 0 plus 1, which is 1. And then if I plug it in here, that's 0 over 0 plus 1. So this is going to be 0. So notice when x is 1, y is 0. That is this point at t equals 0. So the next point, again, we're plugging in the x value. So 1 over 1 plus square root of 1 plus 1. So that's 1 over square root of 2. If I do it here, it's 1 over 1 plus 1, which is 1 over 2. Then if I plug in 2, it's 1 over the square root of 2 plus 1, which is 1 over the square root of 3. Then plugging in 2 into the y value, it's 2 over 2 plus 1, which is 2 over 3. And then plugging in 3, I get 1 over square root of 3 plus 1, which is 1 over the square root of 4, or 1/2. And then the next one would be 3 over 3 plus 1, which is 3 over 4. So notice what's happening here is that at 0, I'm at this point, and then at 1, I'm somewhere right here. And number 2, it's getting closer, and number 3, it's at 3, 4. So notice that it is going in this direction, so that's how we know what direction, the orientation of the curve. So go ahead and try the next example below. Sketch the curve represented by the equation. So trying this out, you could also still get rid of the x squared here, or the x, the square root. The domain has to be greater than 1. And then when your equation will be y equals 1 plus 2x squared. So you know that's just shifted up, and then it goes, it's a parabola that goes right 1 up 2. And then you plug in t values, and so t has to be greater than 1, so you start at t equals 2, and then so you get 1, and you plug in these values, and you notice that it gets closer and closer here, so this is the orientation of the curve.